All right, today we're going to be discussing inheritance, and inheritance involves creating subclasses and how that affects our classes, how it affects our methods and our fields and all the those things. Okay, so first we have a person class. So this is just going to be my super class. It has an age, so my age. It has two constructors, one default and one with a parameter for age. You can set the age, get the age, and it has two interesting methods. One that has a birthday. If you have a birthday, your age increases by 1. And one where they say something. And this one is going to be used to show how interesting things happen. So this one is going to say, I am a person. And then we're going to create a subclass called student. And it's going to have one that says, I am a student. Okay, so we'll discuss this in just a second. So when we create a subclass, we use the word extends. So the word extends creates a subclass. It can only be used once. Only one class can you be extended from. So I could be a person. Okay, student extends person, but student cannot also extend whatever, animal or mammal or something like that. It cannot extend that. So once you have one extension, that's it. Extends can only be used once. Okay, the word extends does create a subclass. So student is now considered a subclass of person. And that means that the person is now its parent class or superclass. These are used interchangeably. And it means that it can access all of its methods, all of its public methods, say that, directly without an implicit parameter, but it cannot access any field or anything that's private. So we'll discuss that in a minute. Well, let's talk about that right now. Why not? So down here, I have a method called pass exams. Now, I called have birthday. So if you pass all your exams as a student and you have a birthday, notice no implicit parameter is needed because it is a child of person. And person has that method have birthday. So it doesn't need an implicit parameter because it is still a person. It just does not have direct access to its age. Okay? So this one only has one constructor. And it only has a default constructor. That default constructor, let me just circle over so you can see this, always has to call the superclass constructor. And this is how we call a constructor of our superclass or our parent class. It always must be written first. Okay? And if you do not write it first, it will run the default constructor. So if I leave this off and I don't do this, delete, okay, it will still call a superclass, but it will call the default constructor superclass. All right, so since I put, hold on, there we go. There we go. Since I put this 14 in here, it's going to come over here. It's calling this constructor. Now, I don't have to put the name of the constructor, just super will do. Okay, and it would call the one with an age. Okay, and it sets the age to be 14. So students are 14 years old to begin with. I could, however, leave this off, and it would make it so that that person, that student, its age will be 0. So student still has an age. Okay, I just don't have access to this field. I have to use the methods to access them. Okay, so 14. So we're going to be 14 years old when you're a student. We're assuming it's a high school student. So, okay. So if you do leave this off and you do not put it, you do have to make sure that you have a default constructor because that's the one it's going to call. So you better have one. Okay, good. All right, so I have a getter and a setter for my field grade. Okay, so it calls the superclass. It sets the grade equal to 9. Okay, so in the constructor, it's automatically setting that grade equal to 9. So constructors still work the same way. They still have to initialize all of the fields. So this one has 2 fields. It has my grade and my age. So it's doing them both. Okay. Then it has a set grade, get age, get grade. And when it has pass exams, as we talked before, it has the birthday. Okay. No implicit parameters needed. And it increases the grade by 1. And the say something that it has is I am a student. Awesome. Okay, then I have another subclass that accepts student. So student has a child called AP student, and that has an AP score. Okay, now this is interesting because again, this super is going to call the super class. So it's going to call student. Okay, whatever this one is, whatever one it extends, that's the one it's going to call. So technically this isn't needed because I am calling the default constructor. Okay, so with student, that's all I have is a default constructor. Okay, I don't have anything with a parameter. But what happens is it calls this one, excuse me, first, but then it calls this one first. So what actually winds up happening is that even though this always refers to the closest parent that it is, so in this case, the AP student's parent is student, it's going to call that one. What winds up happening is the superest constructor is always called first. The highest constructor is always called first. And it's because it's always in that first line. So it's always kind of working its way up the ladder until it gets the highest, most parent, and then it works its way down. So remember, if I tried to put something in here, this one wouldn't work. That's what I'm saying here. If I tried to put 14 in here, it wouldn't work because student does not have a constructor here with a parameter. Okay, so you have to make sure that this one, this constructor here, matches the constructor of the parent class. In this case, it's student. So this one has, again, get AP score. It has those basic things. And this one just has a study for AP exam, just some interesting methods. But the say something is the one I'm pointing out here. I am an AP student. Perfect. All right, so now we have our tester. And now we have to show you how this works. So if we have a person, so let's say Kevin is our person. We're going to construct it. And now Kevin has an age. That's all Kevin has is an age only. But then let's say I create, instead of a person, I create a student. Jesus. Let's say Dave. Okay. Now we have a student and a person. Okay. Now Dave has access to all of the student and all of the person. Kevin only has access to the person. So for example, I can call, I'm going to copy this because, okay, I'm just going to copy this just so I have it in the future so I don't have to mess up typing it all the time. So if Kevin.getAge, that's possible. Okay, Kevin.getAge is possible because Kevin has an age. But also, I'm going to copy the whole thing. Woo-wee. Ugh, Mac, sometimes I get so confused. Okay. But also with Dave, Dave also has an age. So both of these are completely possible and fine. Where is it? There it is. To run. Okay. So Kevin is 0 years old because he's a person with a, I didn't put any value in the constructor. And Dave is 14 because he's a student. Okay, and it ran that constructor there. Okay, so both of them have access to get age, even though student doesn't have age directly. Okay, it doesn't have an age. It is part of the person class. Okay, it's a subclass of the person. Now, I could also do get grade. Now, Dave is the one that has a grade here. Okay. Apparently, I really don't know why caps lock is there. It should not be there. Get grade. This is possible. So the grade Kevin should be in, because it's a default constructor, and I haven't changed anything, he should be in 9th grade because that's what it's defaulted to. Yes. So there he is. He's in 9th grade. Now, the problem with this is, if I try to make Kevin get the grade, I cannot. Okay? Okay, it will be an error to begin with. Okay, I can't even get out of it because get grade does not exist in a person. Okay, so the methods that have to be used, you can use a subclass, can use any of the methods from the student up, in this case, but the person cannot use anything below it. Okay, so the subclasses always have more than the parent class. Isn't that the truth? Okay, so Kevin can have a birthday. That's allowed. Okay, Dave can have a birthday. Oh, date, not date. Dave can have a birthday. Also possible. No problems. Dave can pass exams because Dave is a student. Okay, remember, pass exams will increase the birthday and the age. So right now, Dave should be 16. Okay, because here he turned 15 and here he turned 16 after he passes his exams. So let's see how that works. Now, hopefully you're aware. I'm just going to write it so that you understand. No, not that one. I'm going to have Kevin passes exams, and just to reiterate, Kevin cannot pass exams. That is an error. Okay, because pass exams is not in the parent class, which is the person. Not in person. Cool. Awesome. Alrighty. And then finally we have saying something. So Kevin dot say something. Remember, it outputs. And Dave dot say something. Okay, Kevin is a person, so it should say I am a person. And Dave is a student, so it should say I am a student. Okay, I am a person, I am a student. Dave here is 16 because he had a birthday and he passed his exams. Kevin was 1 because he only had 1 birthday. Okay, and then all of these just output those. So say something had system outs inside it. So this is the basic information about classes, about subclasses, how things work. Okay, then we're going to discuss what happens when the reference class, okay, so we have person, so if we have Nicole be a person, I could have made a AP student, but you know, you get the idea. But I can instantiate her as a student. So this is where we're going to end it here. What I'm trying to say here. This one is the reference, and since we've started this, I've discussed this, that this side, this left side here, is the referenced class, and this one here is the instantiated class. So what happens here? What we're interested in saying is what would happen to Nicole if I ask her to say something. Okay, and what methods will run. So can Nicole run an age if she's not referred to as a student? Well, she is referred to as a person, but can she run get grade? So these are some interesting things that we will be discussing, but this is the basic idea behind classes and inheritance when it comes to classes. All right, have a great day.